We have seen the equilibrium conditions in the earlier lectures. Today we will go ahead with some more problems on the mechanics, where we will be considering the equilibrium, and it's a set of 6 or 7 problems to be solved in the fastest possible manner, because we are not going to learn anything new. Only thing is, these particular problems may involve some cables into it, and cable will be the member which is capable of taking only the tensile load. So only those cables are to be understood properly, and if at all there is some internal hinge, then even that should be solved very carefully. So let us have a look at the first problem. Now in case of this first problem, we have some T-shaped member. The dimensions of that particular T are also given to us, and then its one end is carrying some load which is making alpha degrees with vertical, and that load is 300 newtons. That is at point B. Whereas at point A it is supported by a roller, and at point C it is hinged. The dimensions are also given to us. So all the lengths are known. The vertical distance between A and C, is 300 mm. Horizontal distance between A and C is given to be 150 mm, and horizontal distance between C and B is given to us as 250 mm. Now if you observe that this particular T-shaped rigid body is acted upon externally by exactly 3 forces. There is going to be a vertical reaction at A, VA, because it is roller. There is going to be a vertical reaction at C and some horizontal reaction at C. And so externally if we consider, then we have applied load at B, reaction at C, and reaction at A. And we have got our basic equilibrium condition, that when body is acted upon by 3 external forces, when the body is acted upon by 3 external forces which are concurrent, then and then only the body will be in equilibrium. If there are 3 forces which are acting on the body which are not concurrent, then that body cannot be in equilibrium. So in this case, for the concurrency condition, we can consider the extension of reaction at A and extension of applied force at B, and wherever these two intersect, suppose that intersect at point P, then if that particular point P is connected to C, then we will come to know the direction of reaction. This is going to be, this line actually represents direction of force or reaction at C, and then the problem can be solved very easily. So once we get the direction, our job will be simple and straightforward, because then these 3 forces, they must pass through point P. That was our consideration. And you will also find that over here also you have horizontal force at B acting towards right. If I take the component of 300, it is going to be 300 sin alpha, which is towards right, and 300 cos alpha, which is downward. Of course, this is towards right force will be balanced by the horizontal reaction at C, HC, and the downward component will be balanced by vertical force or vertical reaction at point C as well as vertical reaction at point A. And this is trying to rotate, and A will prevent it. This is how the graphical solution can be obtained. Of course, in that case, this particular length PB should be proportionate to 300, and ultimately you will get even the magnitude of VA as well as magnitude of RC. Even those magnitudes can be very easily obtained, but then this figure should also be drawn to the proportion